This video is on how to do a four corners problem that we're going to be doing in multiple representation. So we're going to start off by reading the top left corner. It says passengers on many commercial flights may make calls from a telephone provided by an airline. On a certain airline, a call costs $3 to make the connection plus $2 for each minute to talk. Okay, so the first thing that they're asking for is the independent and dependent. What we're going to do here is we're going to write a simple little sentence here at the bottom. Blank depends on blank. Okay, and our two variables that we have the total cost. So we know one is the total cost, and the other one is, let's see, the call costs $3 to make plus $2 for each minute. So our other variable is minutes. So when we're answering this question down here, blank depends on blank. Does the total cost depend on how many minutes we use, or do the minutes we use depend on the total cost? What has to come first? Like, what is the cause and what is the effect? The total cost would have to depend on how many minutes we use, because you have to use the minutes first to figure out the total cost. So the cost depends on the minutes. Since the cost depends on it, the cost is the dependent variable. So the dependent variable is total cost. The independent, the cause, is the minutes. So you can think of independent as, independent is like the cause, dependent is the effect. Okay, for the function rule, that's an equation that we're going to come up with. I'm going to start off by saying that the effect, the total cost, in independent we're going to call it X, dependent is always going to be Y. So the Y, the total cost, is going to be the $3 to make the call, plus, we have plus here, $2 for each minute. So $2 per minute. Come on, right. Oh, there we go. So we have the $3 plus the $2 per minute. Okay, if we go down to our table, the process, this is going to be our Y equals 3 plus 2m. And we're just going to fill this out. I always like to start with a real-world problem with a 0, because 0 is our start time. That means no time has passed. And we're just going to go down 1, 2, 3, 4, 5. And we need to figure it out. So when we have this, our total cost is the $3 plus $2 per minute. So if X is our minutes, our independent, Y is our dependent, Y would be the total cost. So $3 plus $2 for 0 minutes. So if I have 0 minutes, 0 times 2 is 0. So 3 plus 0 is going to be 3. For 1 minute, I'm going to pay the $3 to connect plus 2 times 1 minute. 3 plus 2 times 1 is 2. So 3 plus 2 is 5. The second one, $3 plus 2 minutes. $2 times 2 minutes is 4. 4 plus the 3 is 7. Third one. Okay. Oh, sorry. That's a 3. 2 times 3 is 6. Plus 3 is 9. 3 plus 2 times 4. 2 times 4 is 8. Plus 3 is 11. And the last one we're going to do 2 times 5 is 10 plus 3 is 13. Now, if you'll look at our y values, we started at time 0 with 3. We have a 3 here in our equation. The other thing I want you to notice is if you look here like we've been doing in class, where we figured out the common difference, 3 to 5, we're adding 2. 5 to 7, we're adding 2. Each time we're adding 2. So if we look here, this is a lot like that 2x we've been doing. So we're going to find time 0, that's our original start, and then our common difference is the number that's going to be multiplied by the independent variable. Now the fourth thing we're going to do in the four corners is we're going to label our graph. This horizontal axis is going to be x. The vertical axis is going to be y. X is our independent, so that's going to be our minutes. Y is our dependent, and that is going to be our total cost. Now what we need to do is we need to label this graph. When you're labeling it, I want you to pay attention to what scale you're using. So for the x-axis, I went by 1, so I want to start here. This is 0, so I've got 1, 2, 3, 4, 5, 6, and so on. For the y, I can't go by 3s because this would be 3, 6, 9, and I've got a lot of numbers in between. So I'm actually just going to go by 1s right here. You could go by 2s, 3s, whatever you like. I'm going to stick to 1s. 1, 2. Okay, now we're just going to plot these points. So this is our x, and this is our y. So x, y. So when x is 0, the y is 3. 1, 5, 2, 7, 3, 9, 4, 11, and 5, 13. Now we need to decide if it's going to be discrete or continuous. Since the original problem, okay, it's $2 for each minute, we're going to assume they're rounding the minutes to whole numbers. You can't pay for a half a minute. So right now we're just going to have to assume that this graph is going to be discrete. It could continue on. You could do 30 minutes if you want, but we're not going to connect the points because we're going to assume you can't buy a half a minute. If you use it for 30 seconds, you're going to have to pay for a full minute. So that's what we're going to do here. So if you need to watch this again, watch it again. Make sure you're making good notes, and we're going to go over this in class more on Monday.